So, when you're dealing with a right triangle, when we get to talking about parts of right triangles, you really want to look at the sides. That's the sides and the 90-degree angle. So the 90-degree angle is extremely important for you to be able to find. But the sides that make up that 90-degree angle, this one right here and this one right here, those are really, really important to know. And those two sides are always called legs. So this is a leg right here. This is a leg. So A and B are always going to be called legs. Anyone know what the third side of the right triangle is? Yes, the hypotenuse. So the hypotenuse is that third side, so that's C. And the hypotenuse is always the side that is opposite the 90-degree angle, the right angle. So there's always going to be two sides of a right triangle that form that 90-degree angle and the hypotenuse. The neat thing about right triangles are the legs, the length of the legs are going to dictate how long the hypotenuse is. So, and this is the basis for all trigonometry too, is that if you have legs of a certain size, the hypotenuse has to be a certain size. You can't make two triangles with these leg values. And we're going to see in a couple days that you can make a couple different triangles if you know two sides. But when you get locked into the 90-degree angle, the side values lock in. So everything locks in at that point. The angles lock in and the sides lock in, which is why trigonometry exists, because once mathematicians figured out that there was that relationship between the three sides and the three angles, they were able to actually create a whole discipline to study that. And that's what right triangle trigonometry is. But then that's only the tip of the iceberg for trigonometry, because trigonometry goes to all triangles and not necessarily just right triangles. And we can apply it to different angles and things like that. So I love trigonometry. It's my favorite part of geometry. Now, with your right triangle, like this right triangle right here, the Pythagorean theorem was that relationship between the two legs and the hypotenuse. It was discovered by the Greek mathematician and philosopher Pythagoras. And he saw that the sum of the squares of the sides is equal to the square of the third side, which we're going to get to in a second here. So in here, this would be for a right triangle. The Pythagorean theorem is used to find a missing side in, shouldn't be on, it should be in a right triangle. So you need a right triangle. And there are two ways that you can create the formula. Now, the classic version of the formula is a squared plus b squared is equal to c squared. And that's based off of this picture at the top here. But a different way, if you want to think about it like this, is it's going to be, you're going to have leg squared plus leg squared is equal to hypotenuse squared. And that's what A and B are legs, and C is your hypotenuse. So if you just remember a squared plus b squared equals c squared, you're good to go. But you have to also remember where the A and where the B and where the C goes in the right triangle. If you remember leg squared plus leg squared equals hypotenuse squared, then you can look at a right triangle, and if you know where the legs are, you can just pick that information up off the triangle itself. But I would say strive to learn that the a squared plus b squared equals c squared, because that is how you're going to see it forever. As we're learning, you can use whatever you need to make sure that you're getting the right answer and setting everything up the right way. What I would recommend 100% of the time until you're just seeing this stuff off the page and it becomes kind of like muscle memory. Just go through and label the sides. Label one of the legs A, the other leg B, and the other leg, or the hypotenuse C. It doesn't matter what leg gets an A and what leg gets a B, because it just doesn't matter. But the hypotenuse always has to be C. And we're always going to use A squared plus B squared equals C squared. So in this case, you'll get 8 squared plus 7 squared plus C is actually X, or excuse me, not plus, but that equals X squared. Now, a couple different ways you can go about doing this. You can, I'll say, here's the first way. Actually, calculate this stuff out. So you'll get 64 plus 49 is equal to X squared. Then add them up. So you're going to get 113 is equal to X squared. 9 plus 4 is 13. Carry the 1, you get an 11. And then you're going to take the square root of X squared and the square root of 113. And so that means your X is going to be equal to the square root of 113. So that is just doing everything straightforward. We're not actually getting an answer that's a decimal. We're not simplifying a radical, even though you know how to do that. So that's one way to do it. Another way, and I'm going to show you in the calculator how to do this. But here, it says round to the nearest tenth. So I actually, and you all have to actually do the calculation itself. So we want a square root of 113. The square root is the blue key above the X squared on the calculators that I give you. And if you have your own calculator and you need help finding out how to do that, bring it up here. I can figure it out. But we'll clear that out, hit second X squared. Then we go 113. And since it opened a parentheses, I always close it, even though if you didn't, it would work. But if you wanted to do more calculations, you got to get used to closing that parentheses, so I always do it. So you always see me do it. And you get 10.630, et cetera, but it only wants tenths, which is your first decimal place. The 3 is less than 5, so it stays a 6. So this is 10.6. Now, a couple other things you could have done. At this point right here, you could have seen, and I'll move this over here a little bit and zoom it out so you see a little bit more. You could have said 8 squared plus 7 squared is equal to X squared. And then take the square root of both sides and get X is equal to the square root of 8 squared plus 7 squared. Or you could have taken this answer and put it like that, because in your calculator, for some reason it only likes stuff over here. Oh, it's the light above me. Because here's what you can do. When you have this bar up here where you could just type in what you want to do, you could just do this. 8 squared plus 7 squared, and we should get that 10.6 that we got over there. And we did. We got that 10.6. So you can actually just type it in from here as long as you know that you're going to be taking that square root. So I like this because I always recommend that you use your calculator in the final step as opposed to steps at different points along. Because every time you use a calculator, you're going to start getting an approximate answer to these. And the more approximations you get and the more rounding you do early on, the farther away from the actual answer you're going to end up. So keep things like the square root of 113 until you actually have to calculate that out. I always say use the calculator and use rounding at the end of the problem, not anywhere at any of the steps, because you'll just end up being farther and farther away from what is actually the answer. All right, number 2. Number 2 is exactly like number 1. So there's my A, there's my B, there's my C. The numbers are pretty big, so I don't even remember what 15 squared, I think, is like 225, but I don't even remember what 18 squared is. Like 364 or some crazy number like that. So I'll end up jumping in the calculator for this one too. So I know my a is 18, so it would be 18 squared plus 15 squared is equal to x squared. So from here, I do know that if I take the square root of that side, I have to take the square root of that side. So x is going to be equal to the square root of 18 squared plus 15 squared. So x, and I'm going to change the equal sign to an approximation sign. And that just means that we actually rounded the problem. It's not 100% exact. So type in 18 squared plus 15 squared, close the parentheses, and we get 23.4. So this right here is it means is a approximately equal to. That's approximate. Thought I had a little bit more room. That's what you get for looking at the screen. The screen looks a lot bigger than the paper actually is. All right, so this is if you're missing a leg. Or, no, missing a hypotenuse, sorry. Rough morning. So if you're missing a hypotenuse, 1 and 2 is going to be your go-to. If you're missing a leg, B through 6. So once you figure out if you're missing the hypotenuse, you're going to do this exact thing. If you're missing a leg, it's one extra step. That's all it really is. So figure out what your A, your B, and your C is, and know we're going to go A squared plus B squared equals C squared. So I know A is 6, so I'm going to get 6 squared, plus B, which is X, so I'm going to get X squared, is equal to 13 squared. Now, at this point, you can figure out what 6 squared is and what 13 squared is. But you can do this. You could just subtract a 6 squared from both sides and get x squared is equal to 13 squared minus 6 squared. And then at that point, what you can do is take the square root of both sides. And so x is going to be equal to whatever the square root of this is now. So we could just type that into the calculator. All right, there we are. So 13 squared minus 6 squared, 11.53. So we round it to 11.5, and so we say x is approximately equal to that. If you had figured out what the numbers were, it would have been 36 plus x squared is equal to 13 squared, which is 169. Subtract a 36 from both sides. So this is just a different way of doing the exact same thing. So x squared is going to be equal to 133. So x is going to be equal to the square root of 133. And we better get that same answer, 11.5. If we didn't, then we did something wrong, and we're good. It's 11.5. So we know x is approximately 11.5. Every single problem for missing a leg is done the exact same way. So for number 4, we're going to do the exact same thing. That's A, that's B, that's C. So A squared plus B squared equals C squared will give you x squared plus 25 squared is equal to 30 squared. Now we're going to do the exact same thing. Subtract 25 squared from both sides. So we get x squared is equal to 30 squared minus 25 squared. So x is equal to the square root of 30 squared minus 25 squared, which would be approximately equal to All right, so we get the square root of 30 squared minus 25 squared. You get 16.6. Since we have 5, 8, the 8's higher than 5, we've got to round up. All right, 2 more. Again, A, B, C. So we're going to get 12 squared plus x squared is equal to 20 squared. So we just label and go from there. And everything is exactly the same anyway. So subtract your 12 squared. You'll get x squared is equal to 20 squared minus 12 squared. So x is equal to the square root of 20 squared minus 12 squared. And you could have multiplied this out and get 400 minus 144 and then take square root of that. That's fine. You're going to get the right answer. So we have 20 squared minus 12 squared. And so in this case, since we got an integer, 16, we could just say x is equal to 16 because we don't have to round it or anything. That's the exact answer. And, well, first off, any questions on any of this? Yeah?
Are you going to make it simplify like when you get our worksheet?
Not necessarily, but just go with the answer that they're looking for. If they ask for a tenth, you got to type it in the calculator to get those. So be prepared for any of that, but I usually don't make you do that. So that's A, B, and that's C. So we're going to get x squared plus 44 squared is equal to 49 squared. So that's just A squared plus B squared equals C squared. Subtract 44 squared from both sides. Now, at this step, if you've noticed in every single problem, I didn't subtract anything. I just kind of wrote it like it is. You actually can't subtract 49 squared minus 44 squared without actually doing the powers. Because this is like saying x squared minus y squared. Those are two entirely different things. 44 squared and 49 squared are two entirely different things. So we can't add, subtract, multiply. We can multiply them or divide them if we needed to, but we can't add or subtract them. So that's why we always get this step here where it's 49 squared minus 44 squared. And one other thing that you might want to think about when you're missing a leg like this, you're always going to get the largest number squared minus smallest number squared. Notice here it's 49 squared minus 44, so the biggest number minus the smallest number. Up here, same thing, 30 squared minus 25 squared. Over here it was 13 squared minus 6 squared. This was 20 squared minus 12 squared. So it's the biggest number minus the smallest number when you're missing a leg. So I know x is going to be equal to the square root of 49 squared minus 44 squared. So x, I know this is going to end up being an approximate again. So clear it out. Let's do 49 squared minus 44 squared. 21.56. 5 or 6 is greater than 5, so I have to. So not that 5, but when you're rounding, if you're 5 or above, you have to round the next number up. So that's 21.6. All right.